In this video, we'll be looking at scientific notation. A positive number is written in scientific notation when it is expressed in the form a times 10 to the n. And notice a is between 1 and 10, where 1 is inclusive, but we have to be strictly less than 10. And n is an integer. For example, 2.5 times 10 to the fourth. Scientific notation is helpful when you're representing very big or very small numbers. The steps to convert from decimal to scientific notation are 1. Write the number in the form a times 10 to the n. Step 2, we want to determine the number a that's in the front. We're going to move the decimal point in the given number to obtain a number a that is greater than or equal to 1 and also less than 10. Next, we want to determine n. This is the number of decimal moves that you are required to take. If you're moving the decimal to the left, n is positive. If you're moving the decimal to the right, n is negative. For example, let's write these numbers in scientific notation. In this first example, notice where the decimal point is. The decimal point is over here. You don't see it, but it's understood to be on the far right. Let's count the number of times we need to move the decimal until we get a number that is between 1 and 10. So we need to move it 3, 6, 9, 12 times. If we put the decimal point here, we get 7.4. And we'll do times 10 and count the number of moves we made. We made 3, 6, 9, 12 moves. And since we're moving the decimal point to the left, that is a positive 12. So we have 7.4 times 10 to the 12. Notice that this a value out front is between 1 and 10, and the exponent is an integer. In the next example, again, we want to move the decimal point until we get a number that is between 1 and 10. Right now, the decimal point is understood to be to the right of this last zero. Again, we don't see it, it's understood to be there. Move the decimal point 3, 6, 9, 12, 13 times, and we'll get 1.8 times 10 to the number of moves, 13. In this example, notice we need to move the decimal point to the right, but we're still looking for a number that is between 1 and 10. So to do that, we would need to move the decimal point once, twice, 3, 4, 5, 6, 7, 8, 9 times to get to 9.2. Times 10 to the negative 9. This time we're going to make it negative 9 because we're moving the decimal point to the right. Notice that a decimal point is a small number. That's an indication that your exponent will be negative. In this example, again, we want to start by moving the decimal point until we get a number that is between 1 and 10. So 1, 2, 3, 4, 5, 6, 7 moves will take us to 8.09 times 10 to the negative 7. Again, we want a, the number out front, to be between 1 and 10, and the exponent is the number of moves it took. It took us 7 moves to move that decimal point to just past the 8, and we want to make it negative 7 because we're moving the decimal to the right. Again, a decimal to begin with is a small number, meaning we have a negative exponent.